So welcome to day 2, where if you thought Thursday was chaos, today is real chaos. So we introduce a bunch of new features today. So we're going to have rotating grid fees that are adaptive based on what's happening in the energy market. We're going to have new devices that are going to be added to the community that teams can control if they're able to with their algorithms. So it's just chaos on chaos. So let's see if we can again find the beauty in the chaos like we did on day 1 and 2. So yesterday, a lot of the teams were doing good efforts to adapt their algorithms based on the learnings from day 1, and I'm really interested to see how things change based on that. So before we get into some of the kind of details and logistics about how we're going to run this today and do kind of a debrief on day 1, just retrospective, Ed, if you want to say a couple words, I'll delete all.
Yeah, I mean, just very brief from my side. I mean, we have really learned a lot in the last 2 days, and then on the first day was the collaboration, and it was really cool to see some surprise behavior of you guys actually sharing your knowledge between each other on the strategies, and that was really cool. It was a lot of value for everyone. And then on the second day, we had a really interesting discussion with the DSOs. They came up with some really cool features, which are actually bleeding edge research in terms of grid edge fees creation. So yeah, the team has translated part of these of the input of the DSOs into the simulation, and I would already bet for sure the whole thing breaks because just looking at the strategies you have done like on the first day, and now introducing this kind of the next variable, which is the grid fees, we definitely saw deficiencies also from our side in the simulation. So and thanks to you, kind of we have now a clear idea what are the next features we need to put inside, and it needs to be a longer simulation so that you have more data, more time to train the algorithms and so forth. So we learned a lot from our side. Thanks for this, and yeah, let's see the chaos evolving. Then I'm curious if any agent's gonna survive that.
Okay, connected through web, everybody. Good. Let us go. Experiment 3. And just confirm when we're good, Chris.
And it's launched.
Nice. Happy Saturday, everybody. Thanks for being here. Are we seeing trades? All right, seeing Greenlytics trade. VUCA, awesome. VUCA looking good. Green looking good. And OLI looking good. Awesome. We are up and running. And here's what we want. Here's the question. How might we evaluate the performance of a local energy market run through the D3A? Using results from the previous 2 simulations and the set of baseline results, come up with a set of analyses that measure the performance of your team's agent and the performance of the local energy market as a whole. If your agent wasn't trading for a certain amount of time, just take the time it was trading compared to the baseline, and that would be fine. And if you know that your agent wasn't necessarily performing the way that you wanted it to, it's fine to also analyze other teams' agents. So a little bit different than the challenge questions for experiment 1 and 2. This one, as you go, like interrupt us during the silence and tell us if you find an interesting result. So we'll make this more of a rolling conversation that might help teams also investigate something else. If they say, oh, that's a cool chart that they made with that data, maybe I should try and come up with something similar for my agents, for example.
Can you tell us a bit about the baseline? What is it?
Sure. So the baseline is all template agents. So it's with just the linear strategy. So the baseline is not it is not just trading at the market maker rate, for example. There still is a local energy market, but it's without your strategies. So if you want to analyze just the baseline too, for example, and just say, here's a way that you might evaluate the local energy market when you compare the baseline to the next one that we run, that's great too. So this is totally open in terms of how do we evaluate the performance of a local energy market? Because right now we have all these different metrics, their energy bills, self-sufficiency, average market prices, but what does that actually mean and what can we do with that information? So,
maybe to add to this question, so there was ideas already, but nobody really went deeper on this. I think it could be possible to create some sort of index where let's say, where a bunch of KPIs feed into this index. And let's say if you look at a community and you see this index in real time, and let's say the index gets into positive, it means that there is maybe some optimization potential, meaning that you could add maybe some sort of assets or a type of strategy, and the overall balance could be better, meaning that there is still some potential that you could earn more money and some others are saving more. So I meaning as an overall the whole community. And if the index goes below zero, let's say it like this, then you would say like, okay, adding any other asset in there, that production asset or what type of asset decreases overall return on income, ROEs. So where you just look at the index and see, oh, here we could do something. And if it's zero, it's like an optimum spot. I'm not sure if something like this is possible, but the one who comes up with such an index, I'm happy to put the name on this and call it the name index. And then we put it as a KPI into the results.
Okay. Cool.
Colin, just to confirm, right now the grid fee is zero, right?
Right now, the grid fee is, so we have 2.5 cents at the grid level,
okay,
0 cents at the zip code level, and 2.5 cents at the community level.
Okay.
So the total of 5 cents, which means that the market maker rate is actually lower than 30 cents, and that will change at right around midnight, or yeah, I think right around midnight. This is really, really interesting. So let's compare one of the template strategy batteries to what's happening here with these batteries. So we see, looks like a lot of price variation within the slot. Unfortunately, I can't see exactly where those are. Maybe that could be an interesting add. But there's a lot of very small trades in and out, even in the middle of the day. Sometimes you're selling energy, which is really interesting to see. So let's see if one of the houses also. Yeah, you see the battery strategy is really consistent with the template agent, where it just ramps up at the beginning of the day and ramps down. So there's a lot of things going on in the middle of the day that seems like the teams are able to take advantage of. Ah, look at VUCA. So VUCA is buying right in the middle of the day, much later than Greenlytics was buying. And they had all this going on that's really interesting.
That might be due to the PV profile, because accordingly the optimization, what we are doing is that we are using the PV for the house requirement, and the rest we are saving we are charging the battery. That might be the reason.
So you're fulfilling your load first, and then you're selling directly to your storage?
Yes.
Cool. So 0 cents at the grid level. And oh, it's madness. It's anything goes. So you can trade for free in the market right now. So let's see what happens compared to day one.
Which means that also the market maker will have a very small price, and the feed-in tariff will be very high as well.
So we should expect it to happen within a narrower band.
They said, okay, for each for the grid peak, they want to try to keep it below 14. So their idea is that they wanted to measure the grid loading each 15 minutes, and then based on the measurement, decide what the fee should be. So they have a chart here, and if the peak is very low, the fees are really low, and as the peak starts to increase, they start increasing the fees. And I think they do that either like linearly or exponentially. So when it gets to the top and it starts to pass the peak, the fees start to go up very quickly. So this more and more into like the danger zone, they can increase the fees. And based on our conversation earlier, I think that's really interesting because maybe the DSOs would, ping out what these fees are every 15 minutes so that the homeowners know. Or if the homeowners and algorithms, if they know this relationship that a peak of this equals a fee of this, then they could also calculate what the fee would be if they had access to the transformer measurement. So I think it's kind of interesting. I tend to like this relationship because it's a very passive way to control the fees. So, it's based on an algorithm. So anyone who has access to the algorithm could figure out what the fees are going to be because there's this reasoning behind it. But I think it's still kind of up for discussion how that would be communicated, or, what information different parties would have in terms of measuring and then communicating what the fees are. And I mean, based on this, if you are the data scientist and you know the relationship and what the profiles look like, then you would be able to very accurately predict what the fees would be if you had a forecast. So I think that's also interesting.
Already some really interesting results with the grid fee changes. Looks like we're due for another one here. We'll see where we go.
Yeah.
There's but if you look down in the at the different strategies, so let's look at one of the PVs. So day one, we had 2.5 cents on both of the markets, and you see that the PV minimum price was relatively low. When you drop the grid fee down to 0 cents, the reward for the grid for providing PV went to 19 cents at the very bottom. And when you had just the 2.5 cents, it was down at 16.5 cents. So your reward is definitely changing. And it looks like, just based on that, the prices for the batteries also kind of, and the utilization of the batteries change as well. I guess I think VUCA had a better example. Yeah, I think it's a little bit tough to see exactly what's going on in the results, but curious to see how you might evaluate that. We're getting a ton of good data here.
I think when Chris and I ran the baseline yesterday on day 2, that was when there was 0 grid fees. And we were kind of surprised at first because our energy storage wasn't doing anything with the template strategies. And then we realized it was because the PV could just sell back to the feed-in tariff, and the energy storage, couldn't compete with those prices to buy the energy. But then, in the experiment results, I posted some screenshots. So in the base case for the second day, the storage isn't trading, and then OLI was trading with their storage during that time, and then the other 2 teams had charged their storage. So that was interesting to see that change from what we saw yesterday. So the grid fees have increased for the community. So the grid fees are 0 for the grid, and then they're 3.75 in the community.
So we expect that to make trading harder between the communities. A much higher PV peak today with the most recent day. And it looked like the past 2 days we have a couple periods of total self-sufficiency where there's no purchase from the market maker at all.
Cool. I think, Colin, you're not sharing your screen anymore. I don't know if you intend to.
Thanks.
Thanks.
Yeah, so look, this is the inside the zip code market. You see a couple periods here where the PV peak is at its total highest here on this day. That was no grid fees between communities, but a grid fee at the market maker rate, I believe. But then you also see these periods here on either side of the PV when the PV is kind of ramping up, where the community is totally self-sufficient and doesn't interact with the market maker at all. But if you were to disconnect, the community would have been self-sufficient from the market maker for the entire period of time. So 6 days complete, coming into the last day here. So this one will be really interesting because your agents shouldn't be able to trade with the market maker rate because the grid fees make it prohibitively expensive. So we'll see what ends up happening here. We should see it pretty quickly what the export and import looks like. I guess no export import is available. So the batteries, yeah, the battery got used up, I guess last night almost immediately.
So, Colin, I guess there is a congestion. So the grid prices are higher than batteries have incentive to sell or not?
Yeah, it should be incentive to sell your storage, and it should be a higher price for the energy because you can't get it anywhere else. So it basically models that you are islanded away from the grid. And we'll also see some unmatched loads here, or unmatched generation for the PV, I'm assuming. It's interesting, I'm looking at Greenlytics PV, and it looks like it has no sales at the period of highest generation, even to its own loads, which is kind of curious. So maybe its load is getting a better price from other PVs. OLI seems to be selling the most.
So which price was that, Colin?
The price, let's see. It sold at 15 cents once. But the average market prices we can look at. Chris just pinged me. He said that the templates are. What are you seeing, Chris?
So the templates are selling quite some energy. If you look at PG2, for example. So my first impression would be to say that the PV stall are selling to some of the bids of the other house instead.
Mm. So they don't realize that it's at a premium, and so are willing to sell at a much lower rate.
Yeah.
But I guess that's the market happening. Yeah. Cool. Yeah, so that's so interesting. Because there's energy is at a real premium when there's no energy available from the market maker, except when there's an overgeneration, and that's when the price should drop almost to zero, right? Or I guess even negative.
It would be really interesting to see, you know, when we emulate the market maker with wholesale prices, and we take some curve of a week where there was a couple of times negative prices, just to see what's happening. In principle, my agent would scream to me at home, like, "Hey, can I turn on everything?"
Suddenly your dishwasher and your everything
Yeah, well, wash machine starts to run empty.
All your lights turn on. I'm really glad DSO team we came up here with this experiment. This is great. I feel like we'll have a lot of interesting results from that. Great ideas.
There is also an interesting results on the if you look at the zip codes market. And so since the grid fee are higher, it means that to get to market maker, people would have to pay more. And so the template strategy should not be able to buy because they are limited to 30% to 30 cents per kilowatt hour. But here in this example, we see that they are still able to purchase from the smart community, which means that both community in critical period like this can benefit from each other. So the community that only consume energy can still purchase some of the energy. And so the smart community can sell its energy instead of, as we saw, some PV to be curtailed. Yeah. Okay.
All right, simulation finished. Great stuff. Yeah, we have some cool results here, and we can get started. So we have Jan and Arjun from the DSO team. Anybody else join just for the debrief?
Yeah, I think Rick might be joining, but
great.
Just go ahead and check where he is.
Cool. So what we'll start with is the Mirrorboard. We had some really interesting results here. So just to remind the DSO team, the way that we talked about yesterday to design the simulation, we have the same data running for 7 days in a row. And so just with different grid fees being changed. So we have some really interesting results that show what happens when you have the grid fees changing, especially this very last day where you have like this island scenario you can't buy from the grid. Okay, by deleting the grid fee on the second day, the zip code has bigger peak imports. So I'm not sure. I don't remember if I put this one or not.
Yeah. So on the first day we had a total of 5 fees to get to the market maker and to the feed-in tariff from the house to the grid. And on the second day we had 0 fees. And what's interesting is that if you have less fees, then the import peaks are a little bit higher. This always one like. So the peaks are a little bit higher on the second day with 0 fee than if you have grid fees.
I think we'll definitely need to do a deeper analysis, but you can see that there's pretty high differences in peaks in both import and export, depending on how the grid fees change. So that's something we'll do more analysis in. Chris?
Yeah, so on the last day we had, it was the day where the grid fee was the highest. And so to get to the market maker, the house couldn't make it to the market maker because the grid fee were much higher. And so the market maker price would be more than 30 cents. And so what's interesting is that community B is a community of consumer. And the last bidding price that they have is 30 cents. And so by the increase of the grid fee, they are not able to buy from the market maker. And so if there was no local trade, that would result in a power outage for this community. But here they can benefit from community A, which has a surplus of generation. And as shown with the 2 circles, the community B is able to buy, to still purchase some electricity, even if the grid fee are high. And so both community could benefit from each other.
Super cool. DSO team, any reaction to those first 2?
Yes, really nice, I think. So you expect some effect, but to hear this, it's good to see that the algorithms are able to cope with the grid fees, and so in some way they save the big community from being completely blacked out. So yeah, that's I think what we like to see and to learn from. So very nice. Yeah.
I mean, this this basically shows that if at the top something goes wrong, you know, the markets start to fractionalize themselves into smaller pieces and supply them at the lower scale, at the lower levels. It's very interesting to see that. No, I wonder how such a result would look like if we would have a simulation with more hierarchies and more communities running.
Sarah, do you want to run us through the grid fees, or the DSO team too, if you want to kind of share your thinking on why the grid fees were updated the way they were?
Yeah, I made this spreadsheet based off the one that Stedin sent us yesterday. And yeah, from Stedin looking at this, I mean, the baseline was 2.5 cents for community, zip, and grid. And then what Stedin sent us is whether the fee should be 100% of the baseline, 150%, I think 3.75, maybe that was 175%. So I just adjusted the fees each day according to the way that Stedin set it up. And then on the right, we calculated the total fees that are going to be paid when the community is selling to the grid and when community A is selling to community B. So we kind of knew then what the total fees were.
Yeah, so what Chris's examples earlier that showed that community B benefited even when there was an outage between the market maker rate. The community A and B grid fee was still really high. So it could be interesting to see what would happen if you cut off the market maker and you reduce that fee, if that just affects the prices or actually can affect the total amount that you traded too. Yeah, so what we have currently, what we ran today for experiment 3 was proactive grid fees, where you change the grid fee at the beginning of the day and expect a certain result. What we will have running for the November hackathon and very shortly, so we can experiment on it, is reactive grid fees that take into account the amount of energy that was traded in the last market slot, for example, and be able to change the grid fee up or down based on how much energy was traded. So we have that working locally. It's just not working on web at this point.
And that's also a good indicator for how the community is doing as well. So if the grid fees are increasing up to a certain level, that can be an indicator to compare the two communities with each other.
Yeah. So, Arjen, what we were discussing, with the team said, okay, they were surprised by the grid fee. It was clear. Sarah was kind of talking, and then she stopped talking because she had to change the grid fees. so it was like a surprise where it's going to go. So they couldn't really react. And so a question came up, how would it actually look like in real time, in reality later? Would there be kind of an advanced would it be known where the grid fees are going in advance? Because that could help the teams a lot. And so we were thinking maybe we add something to the UI or to the output where we have, we see in real time here what the grid fees are at different markets and in the past. And we were thinking like how to improve also the DSO view on the markets. So one of the next features that we're working on is adding a map, which will come at where you basically click on a market and you see kind of the area on the map, which area is inside the market, and then we could put this kind of graphs that you see here, the 2.2 cents, and then right next to it a small chart just showing the capacity of the market in terms of trading capacity. And maybe the price development of the grid. So I think the price forecast, or at least some kind of indicator to the algorithms, could help a lot. But of course, this is kind of more of a political question, or some sort of that needs to be answered. Can this be known in advance or not?
All sorts of ideas are coming up to me at this moment, and I think it's good to have an offline brainstorm and with your team, of course, to see what we can do on this. For example, for Groene Meent in The Hague, we have both the topology as the measurements for the substations. We are building that as well, so you can make it more real time and show indeed the topology, so the location of the community, all the things you just highlighted. I think we can make it one level more detailed if we are willing to do so, or if we see value in that.
Great. Chris or Sarah? I don't remember who posted this one.
So the baseline is on the right, and then our experiment is on the left. So we saw on the second day there were no grid fees, and so in that case, in the baseline, the storage didn't charge or discharge because all the PV excess production was just being sold to the feed-in tariff. And then the difference we saw is even though the grid fees had dropped to zero, OLI was still charging their battery. Maybe they had some internal optimization for each house. That was, I'm not sure, they could comment on that. And then Green and VUCA, they had charged their battery and they were just keeping it charged. So I just noticed those differences.
Yeah, if you look at the battery strategy for green storage, for example, it really looks like grid fees has a big effect on how the battery was used, and they didn't change their strategy at all the whole time. So even on the same data, you see that they were generally keeping their battery at a very high rate, and then a couple different times they would dip down a little bit, and then as the grid fees started to increase, they started to discharge more and more of their battery because it was more profitable to do so based on their strategy. So cool to see how you can really influence trading through grid fees.
Colin, can you also look at VUCAs? It's if you look at house 4, it's also interesting. I think we had more or less a similar strategy.
Oh, cool.
But we were trading a bit more.
Yeah, this battery made €7 in a week. This green storage one.
Yeah, I just pulled up the baseline, and the baseline is €2. So yeah, it really, I guess, focused. It only was discharging when it could make a really big profit.
So what's that multiplier? A little over 3x in a week. That's crazy. Looks like the OLI storage 11 was minus 4.28 as well. This is live video of what's happening right now when teams are changing their strategy on the fly.
Yeah, for the green storage, they were selling, like their maximum sell price was 26 cents, and then that was compared to 21 cents. So somehow they managed to sell for higher, which is pretty cool. I don't know exactly how that worked out.
All right, so very good, great results. Let's go quickly through some of the feedback and ideas from the conversations that were happening, and then we'll have the teams present their challenge question. Thanks, Chris. So a couple of interesting conversations. Mukund and Ed got into it a little bit. Mukund said that getting into too much detail in terms of results and facts and figures and numbers can scare consumers away. And so Ed was saying that we need to find a way to absorb that complexity, but also provide, don't limit the freedom that consumers are able to have. So we're basically translating between two completely different languages and levels of detail. Mukund wrote his thesis using the D3A, and we wrote a blog post with him to talk about his research and some of the results. And he went in, especially with a couple metrics that we hadn't thought about before, like social welfare. And so I think Mukund will talk a little bit more about that in there, the analysis of the results. But if you have anything to say now, please jump in. But I'd recommend you read the article at some point. If you click on the source link up here, you should be able to see it. And then also the governance of local exchanges. Right now, it's in different countries and different setups. But how can we involve DSOs, communities, data scientists in the governance process and make it so that incentives are still aligned between all, so that one person doesn't have all the power, but that you can also make sure that everybody has a voice. This is great, everybody. Okay, let's start. Let's just go left to right. Greenlytics, you want to start?
We started with coming up with, some hypothesis what we want actually to KPI to represent, to try to go a little bit top down in the creation of the KPIs. So one thing that we thought about is decentralized versus centralized optimization. So in this kind of market structure, it's kind of a decentralized optimization because you have those agents that are competitive that try to optimize for themselves. And then an interesting metric would be how close do you actually get to the global optimum if everyone would collaborate maximally. So, and then the second one was comparison between the actual, so for one specific household or agent, so what is the actual outcome of the trading compared to if there was no local energy market, no community market. So basically, what's the difference between trading at the market maker price and feed-in tariff compared to what we get out from the value? And then last was the relative comparison then. So you have a community, okay, now let's say you have a community, how much value can we capture with our assets or our households compared to the relative, compared to the sum of all the value that is created by the community market. So that's basically a metric or KPI that tells you how well you're performing in comparisons to others in the same community. So if you would go, see here, if you would go down a bit, so if you start with the first one, that would be maybe the best one is this third, Postit actually. So one way to calculate this, the first question, or to solve the first answer the first question is to do to take the data that you have, so the production and all the storage that you have, and also the loads profiles, and then run just a full optimization given perfect information. So you basically know exactly what the what's the PV and the loads are going to be in the future, and then you can compare that with what was actually happening, and see that probably some households will have less, optimal results compared to this optimization, and some might have better because they stole or they captured some of the value of the other assets. And then, but for sure, the total amount of value created by the agents, the distributed agents, will be less than the total optimum, the global optimum for the full centralized optimization.
All right, Luca.
So we have looked at the problem from the point of client's view. So we imagine that the agents as local aggregators of several loads, PVs, and storages, and the clients would like to see if their PV and storage investments perform to minimize the cost of energy purchase and maximize the return of energy sales. So how can we show these metrics to the customer? Here on the graph, what we do is actually imagine here that we have also the linear strategy that you have given. So anyone can implement the linear strategy, right? So in changing environments, we can compare our performance with the linear strategy, how better our strategy is doing compared to a linear strategy that anyone can implement. So in such a graph, if we also have the linear strategy result and the VUCA strategy, but it also needs to take into account that it's not only the load or not only the PV, not only the storage, but the total of what the house has as devices. So that could be one metric for the clients to see how their agents are performing. And even though we believe the competition is limited, I mean, in one local market, I don't know if there can be thousands of agents. It can be in big cities, maybe, where there are big districts. Like in Istanbul, we have districts in a size of 1 million citizens. Might be one. Then what we would do is we take these thousands of agents results into account and show in normal distribution how the agent of the client is performing. Then the client might use that metrics as a game, so we give them a nice gamification. So if we look at the other problem, the performance of the local energy market as a whole, here we believe that the most important thing is to overcome the congestions. So this is more of a role for DSO to set up a trade strategy with dynamic grid fee structure, which will enable agent algorithms to trigger battery devices to overcome the congestion. So the most important in here is the service quality of energy distribution at first. And then the second is self-sufficiency. So how much this local market is settling inside. But I'm not sure about that yet, because if this local market can also buy cheap from other local markets and sell expensive, then this should be a plus for the community. But if we look at the this market from a client point of view, they might be more interested in how their house is performing than the community. Then I see the community problem more from the DSO perspective. So self-sufficiency can be a goal. And as we discussed about the grid fees, also the grid fee comparison between the communities can also be the outcome of the performance.
Okay, great. Thank you, Vuka. Oli. Oh, sorry.
With us, first thing, as I was mentioning earlier, one way to analyze the market result, and that can be collected through the customers who are being satisfied by being part of the market, also is customer satisfaction, where you can create a matrix between 0 and 1, where you try to assess where they are at exactly based on a particular time period. So let's say you can include the weight for how much of their total energy needs are being met by trading locally in the market, and how much of their revenue that they're saving. So based on that, you can arrive to a number between 0 and 1, and based on that, you can also go up on the hierarchy to see different levels. So if you divide it also based on, let's say if I'm between 0.8 and 1, then my satisfaction is high. We decide that matrix already. So we can see as we go up with different houses taking the part in the market where the average number lies. This can give you an indication of how the market is working. And I think this could also be used by a data scientist who is also creating strategies to understand how much profit and how much of their customers' needs are you satisfying with the kind of algorithm you're developing.
Great, really wonderful results, everybody. Really excited to see where you go with it next. We're trying to get the results for experiment 3, so you can play with those as well as you go forward. So we'll let you know how that goes. And we'll get some data ready, and we're setting up for experiment 4. So we'll do a quick briefing of what experiment 4 is when we all come back, and then we'll get started.